Welcome back to our channel. So in the previous sessions we have seen the circular linked list. Now in this session we will go with another concept, that is double linked list. Right, the name itself indicates here we have to establish two links for every node. So till now we have used a normal linked list, that means a single linked list where every node is having one data field, another one is a pointer field or an address field which holds the address of the next node. Now in this double linked list, the name itself indicates every node will be having two address fields. That means every node will link two different nodes. So one is the next node, another one is the previous node. See, so how to represent this double linked list, a node in a double linked list. So a representation of a node in a double linked list is this one. That means, so it is a node which consists of three compartments. The middle one is the data. So next, rightmost one is the next, leftmost one is the previous, right? So see, this is the address field and this one is also the address field, right? So this stores the address of previous node, and this holds the address of next node, right? This holds the address of previous node, this holds the address of next node. Now if it is a starting element, so that means if it is a head, then the previous, so there will be no previous node. Okay, so this is a head, that means a starting element, so it doesn't have any node, the previous one, so there will be no link for the previous node. So that's why here the previous must be equal to null if it is a head. Here if it is a tail, so we know that a tail is a last element. So if it is a last element, then there will be no other node, so the next field will be null. Right? Hope you understood this one. If it is a only single node, then previous field will be null and the next will be holding the address of the next node. If this node is a last node, that is a tail, then previous will hold the address of previous node and next there is no other node, so next will holds the null value, right? Then so this is the representation of a node in double linked list. So here we are using two different links. So that's why we are using this double linked list. Right? Now let us create a structure for this node. So how to create a structure for this node? So here there are three fields. One is data, two are the address fields. Simple. So we know that struct node, which we have created for single linked list. So here we have to use struct node star previous, so self-referential node. Next int data, so integer or a character, whatever it may be. Again struct node star next. So this is the structure for a node in double linked list. Okay, so three fields, two are the address fields, previous and next, and another one is a data, right? So hope you understood this one. So if it is clear, then we can write the code very easily for creation and display. So in this session we will see the two operations, that is creation, I mean how to create a double linked list and how to display the nodes of a double linked list. So that will be very easy if you understand this concept. Right. Now let us move on to the operations. Yes. So first one is create. So how to create the node? See, we know that here also the same concept which we have studied in the single linked list. So here also we have to allocate the memory by using the dynamic memory allocation. So here we can use the new is equal to first statement, new is equal to struct node star malloc size of struct node. So automatically the address will be assigned for this new. Now what we have to do, we have to read the value data. So scanf %d ampersand value. So if it is a integer, we have to use this %d. If it is a character, we can use the %c. Right. Now we had a value and node. Now what we have to do? So we have to place this value in the node. So whenever we execute this one, this will be created. See. So this is the previous, this is the next, this is the data, and this one is the new. Right. Now value, if we take excuse me, 10 as a value, right? Now we have to insert that one. So it is the first element, right? It is the first element. So the previous will be null and next will be null because only one element is there. So that's why we can simply write it as new of previous is equal to null. New of data is equal to value. So we are placing the value. New of next is equal to null. Hope you understood this one, three statements. So initially it is null, it is 10, it is null. Right? So we are creating only one element. So that's why we are just placing both the null values. Now, so in the second iteration, we have to read another value, then we have to place the address in the next. So that's why here we will check the condition. See, if head is equal to null, so initially consider the head. So we have to consider the nodes head, tail, temp. So all are the pointer values. All are the pointer variables. So that's why similar to our new. Right. If head is equal to null, then we have to assign the head and tail to this same node because initially these both are null. So head doesn't points to any node. Similarly, tail doesn't points to any node. Now we have inserted one element. So automatically the head and tail will be pointing to the single node, the same node. That's why we can say here head is equal to new, tail is equal to new. So automatically after executing this statement, so this is the head, this is the tail. Right? So all the three, new, head, tail, all are pointing towards the same node. Now else now this part will execute if in the second iteration, from the second iteration, right? So after completion of the first iteration, second iteration, it will again read the value. So 20, if you read the value 20, and one more node is created here. Right? Now new is this one. So this is not a new. This is only head and tail. See, this is the second iteration. So 20 is the element. So initially, after reading the value, new of previous is equal to null. So here it is null. Data is equal to value. So here 20 will be placed. Next is equal to null. Again null. Right? Then see, if head is equal to null, head is not equal to null, because, so let it be 1000 is the, okay, we will write here 1000 is the address of this one and 2000 is the address of this one. So head is pointing to the 1000 memory location, so head is not equal to null. So that's why this is condition fails, automatically else part will be executed. In the else part we have to write what we have to write. So we have to place the previous field, that means the previous address field should be holding the address of the previous one, right? And in the head, the next field, the next address field should hold the address of new. Hope you understood, right? So this should not be null and this should not be null, because this is not a single element, it is having the second element. So first element have to store the address of second element, and the second element, in the second element it should hold the address of first element in the previous field, right? So that we have to do that. See, first tail of next. So tail of next is equal to, tail of next means this one, tail of next. What it should be? Tail of next 2000 should be placed here, right? So 2000, because 2000 is the second node, the address of second node should be placed in the address field of first node. So tail of next is equal to new. Tail of next is equal to new. Now here we have to place, in the null place we have to store the address of head, right? So here it should be 1000, because this is the previous one, right? This is the previous one. Now what is the position here? New of previous. New of previous is equal to tail. Why we have to take the tail? Why we should not take the head? This is the question. Because this is the second element. If you go with the third element, if you place the address of address of head there, automatically it will be wrong. So we have to move the tail from first element to second element. So our next one is tail is equal to new. So automatically here the tail will be released and it will be assigned here. Okay, so hope you understood this one. Now see, this is the second iteration. In the third iteration, if you place 30, so one more node is created here. Right? So see, 30, new of previous is equal to null. So this is null. So it is new, right? It is new. New of data is equal to value. So 30. New of next is equal to null. Again null, right? If head is equal to null, head is not equal to null, so else part will be executed. Tail of next equal to new. What is the tail? Tail of next. So this one, tail of next. See, this is the next part. So tail of next is equal to, let it be the address is 3000. Tail of next equal to new. So that means 3000 will be placed here. So automatically a link will be established from here to here. Next, new of previous. What is the new of previous? Here new of previous is equal to tail. Is equal to tail. That means 2000. So here we have to place 2000. Okay. Next, tail is equal to new. Tail is equal to new. So tail will be replaced here and the tail will be here. Right? So whenever you place the 2000 here, a link will be established from previous node to current node to previous node. Right? So this is how a double linked list can be created. Okay, this is also very simple concept. So all these should be written under some loop, right? So iterations. So we have to repeat these statements until we want to exit, right? So hope you understood this create method, create logic, a simple logic, right? So I am not giving the program completely, just I am explaining the logic. So if you draw the diagram and if you trace every statement, automatically the concept will be very easy, right? So hope you understood this create method, create operation. Now we will go with the display operation. So once you created this one, then how to display the elements of a double linked list. So that is a normal logic which we have seen in the linked list and the circular linked list. See, the same thing we will follow. So hope you understood this create, how to create a double linked list. See, the second one is display. So how to display the elements of a linked list. So we will go with this one. So we have to travel this one. So first just assign head to temp, because we have to travel from first node to the last node. So while temp of next not equal to null, temp of next not equal to null, or simply we can write temp not equal to null. So anything is no problem, right? So temp of next not equal to null or temp not equal to null, right? So if you write the temp of next not equal to null, it will display up to here, and out of the loop we have to again display the temp of data. So if you write the temp not equal to null, it will move until the last node, right? So here what we have to do, we have to print every element. What is the element here? Printf %d temp of data, right? So if you want to print the data, statement is temp of data, and we have to, after printing the element, we have to move the temporary value. So temp is equal to temp of next, and close this one. So this is a simple logic for displaying all the nodes of a double linked list. So in the first one, temp not equal to null, first temp is equal to head, so here the temp will be here. So temp not equal to null, so temp not equal to null, so 1000, here temp is equal to 1000, so not equal to null, it's true, so it will display temp. Next, temp is equal to temp of next, so now temp is equal to temp of next. So what is the temp of next? 2000, so temp will be here at the 2000 position. Now again temp not equal to null, so 2000 not equal to null, so obviously temp of data, it will enter into the loop and it will print temp of data. So 20 will be printed. Next, temp is equal to temp of next. What is the temp of next? 3000. Temp of next. This is the temp of previous, this is the temp of next, this is the temp of data. So temp of next is 3000. So it is assigned to temp. So now the temp is assigned to the next element. Temp is, so temp not equal to null. 3000 not equal to null. True. So temp of data will be printed. So temp of data 30 will be printed. Temp is equal to temp of next. So what is the temp of next? Null. So temp is equal to null. Again, temp not equal to null. So condition false. Automatically it comes out from the loop. Right? So in such a way we can display all the elements of all the nodes of a double linked list. Right? So the concept is very easy. So try to understand this one. So try to write the logic, try to write the program and execute the program. And if you are having any doubts regarding this create and display operations, or any doubts or queries regarding this session, feel free to post your doubts in the comment section, so that I will definitely try to clarify all your doubts. And if you really understood my sessions, like my sessions, share my sessions with your friends, and don't forget to subscribe to our channel. Keep following. Thanks for watching. Thank you.